everyone. My name is IniOluwa Popoola, but I'm popularly known as IniOluwa Afolabi, and I'm a MasterCard Foundation Scholar here at the University of Cambridge. Today, I'll be talking to us on the topic machine learning potentials in chemistry. And thanks to Professor Bamdele Adebisi for this opportunity to share my experience on using machine learning in my field so far. So today I will take us through my academic background, my machine learning background, the past research I've done, and the ongoing research I'm working on here at the University of Cambridge. So talking about my academic background, as an undergraduate, I went to Afolabi University of Technology, where I did pure and applied chemistry, and I was fortunate to graduate with a first-class degree. And as an undergrad, my research interest was purely on environmental sustainability. So in my final year, I worked on absorption of endocrine disrupting chemicals from wastewater using different agricultural waste. That was what I did as an undergraduate. After my undergraduate degree, because of my love and passion for research, I volunteered with my undergraduate supervisor before I went for my NYSC, and I used that opportunity to learn more on what we do on absorption of these contaminants from wastewater and how I can implement, use machine learning techniques in this research area. So after I left, then I tried to also collaborate with different researchers in chemical engineering field, where we also work on different machine learning projects to predict some properties of some biomasses that were used in making clean fuels. So currently, I'm pursuing my MPhil degree here at the University of Cambridge in the ICE group, and my research interest centers on environmental sustainability, how I can use computational techniques to address some of the environmental crises we are facing in this century. So my research interest is purely on climate change, green hydrogen technology, machine learning, artificial intelligence, and absorption technology. So those are my research interests currently. Okay, so talking about my machine learning background, how did I come into machine learning? As a chemist, how did I come to use machine learning in chemistry? It all started from a random conversation with my husband. Then we were not yet married. And because he's in engineering, he got to know about these machine learning techniques, how it's been applied in their field. And because he was so excited about it, he came to me and was sharing the potential of machine learning in his field. And I'm like, oh, wow, that's a good technique, maybe for chemical engineering field. Then at some point, it was in my 400 level, and I was like, okay, since I'm looking for something to work on as my final year project, and I would love to do a bit more than what others are doing. I would like to do something unique that other people are not doing. Maybe this could be an interesting concept that I can adapt to my field and see how it works. Then we started thinking about it, that could it be something interesting that I could use in chemistry. Then when I discovered that, yeah, it could actually work also in chemistry, then I went ahead to meet my supervisor and said, you know what, I just discovered a great technique that they are using in chemical engineering field and in engineering field, and I think we can use it in chemistry and use it in the absorption processes we are actually doing, so that we can automate our experimental processes. Then my supervisor was so happy about it, because it's a concept he's been looking at how he could also apply it in his research work. And he actually found it as a great idea, and I went for it. He asked me to go for it, then I went for it. Then talking about the implementation, I had to actually leverage on the understanding of my husband in the field, and also leverage on what has been published in literature. I did some literature review on how machine learning has been used in chemistry. Then now talking about how to use it in my research as an undergraduate, then we had to sit and actually go through some critical thinking, like, okay, if my husband will try to explain to me this is how it works, fine, and we need data set to train our machine learning model. Then he will explain to me, okay, as an engineer or in engineering field, these are the data sets he needs, and this is what they want to predict. So I will have to adapt that thought process to my own experimental work that I'm doing in the lab and see, okay, what would be my own data set and what do I really want to predict using machine learning? Then after we've done that, we did a couple of work using machine learning for my undergraduate project. And after we did it, we actually tried to validate our thought process through publication to know maybe our thoughts about the usage of machine learning in chemistry is actually correct. So when we saw that, okay, it really worked, then when I was planning to apply for a postgraduate degrees, I became more interested in machine learning. Like, I can't just divorce machine learning from the chemistry I'm doing, because I really want to move away from experimental chemistry into computational chemistry. So I identified a research paper that my current supervisor published that uses machine learning. Then I saw the machine learning model they use. It was quite good. It gave a good result, but I felt there is more that we could do to improve this current machine learning product in this machine learning model in this research field. Then I proposed what I think will work better to my current supervisor, and he was really interested in the concept. And that led to a Mastercard Foundation scholarship for me to implement more of the potential of machine learning in addressing some of the climate crises that we currently face. So what have I done in the past on using machine learning in chemistry? So this is the first major project I did with machine learning in my research. So what we do in the lab is to develop activated carbon from agricultural waste, then use this agricultural waste to remove paracetamol contaminants, which is one of the classes of endocrine disrupting chemicals. But for us to know if a material, like if our agricultural waste or this activated carbon will be efficient, we need to know the absorption efficiency of this material in actually removing these contaminants. Then what I do as an experimental chemist then was to do batch experiment to actually investigate the potential and the efficiency of this material. Then, having known the potential of machine learning that it can actually predict the absorption efficiency for me, I don't need to do the stress. I just need to supply good and enough data set to train my model. Then I felt, okay, the experimental data that I have, I can actually use it to train a machine learning model and see if it can actually predict the properties of my materials in removing this paracetamol contaminant, so that when another chemist come in and wants to use the same material, if they know the operating conditions, operating parameters they want to use, they can actually use the model to just do the prediction without actually going through experimentation again, since I've done the experiment and I have enough data set to train my model. Then we did that, we thought through it, and we were able to develop a machine learning model, which actually predicted very closely, like up to like 98% efficiency when we compare it to the actual value, actual absorption efficiency that we got during the experimentation. And to validate this thought process, to know if it is widely accepted, then we had to publish it out. And that was published in an Elsevier journal. The second one was to model pseudo second order kinetics. It is a model we use in validating absorption processes. And if our absorption data doesn't agree well with this model, probably we are wrong. Then since it's a go-to method that we use to validate our absorption processes, I felt, okay, it's good, but can machine learning do what this model is actually doing for us? If it can do it, that would be great. Then we know it also has the potential to replace the existing method or to improve the existing method in this research field. Then we actually thought through this. I know it was a struggle when we are thinking of how to develop the data processes, the data set that we will need in training this particular model using machine learning techniques. But to validate our thought process again, we had to try to publish it out in a peer-reviewed journal so that people we actually look through it and they will see if it's actually contributing to knowledge. And fortunately for us, it got published also in an Elsevier journal. So afterwards, after my undergrad, I tried to collaborate with some other researchers in chemical engineering field because I was so passionate on using machine learning techniques in any chemical related research. So I collaborated with these people in Saskatchewan, Edinburgh, and in Dublin. And we're working on a clean fuel machine learning project for clean fuels. So the industry wants to go into clean fuel, but they want to know which of the biomasses we give the higher 18 value, because it is this that we use to measure the efficiency of the biomass in being used as a clean fuel. But we want the machine learning to be able to predict the properties of these materials. So we also use machine learning techniques to predict the higher eating value of this biomass, of different biomasses. And fortunately, just like 3 or 4 days ago, it got accepted, and this is the certificate of the acceptance. It's not yet published. This is to tell us that machine learning is widely and is gaining its pace in chemical related research area nowadays. It's been valuable and it's like the research hotspot at the moment. So I actually brought this citation profile to actually confirm what I just said, that chemistry is also, machine learning is also finding its useful ground in chemistry space. For instance, we published this paper in 2020, and within 2020, October 2020 and today, this particular one has 41 citation, and this one has 30 citations to date. It's telling us that so many research is still ongoing in this line. People are still building on this knowledge on using machine learning techniques in chemistry work, in chemistry related research. So as we used to know machine learning to be widely available, widely applied in engineering space, computer science, as opposed to that is now being used in sciences, in chemistry. So there are so many literatures that are coming out on usage of machine learning in chemistry. So it's finding its place in the field now. So talking about the research I'm doing currently in the ICE group here at the University of Cambridge is more of investigating more of the potential of machine learning in discovery of next generation materials for CO2 capture. So in this field, we have existing method that we use, which we call density functional theory, which we use to understand the properties of materials at molecular level. But when the size of our material increases, it takes a longer period of time to get accurate results from using DFT calculations. Then we are looking for a method that can actually complement these accurate results in my field, but that will give this time-saving qualities that we need, because with the impediment of climate change, we need a quick and efficient material. We need to discover materials that will be efficient in capturing our CO2 quickly. So we are looking for a method that can actually help us in achieving that. So in this current research, we are looking at how to harness the power of DFT and machine learning to predict the properties of some materials that we are investigating for CO2 capture. And Those properties could be the absorption capacity of the material, the selectivity, the stability in humid environment or in water condition, and how can we recycle the material to make it sustainable. So we are also investigating machine learning potential in this regard. This is to tell us that there are so many things that we, as a chemist or in chemistry, we can use machine learning to actually do. Like I did in my undergraduate, it was for wastewater treatment, but this time around, we are using it more in CO2 capture. We are investigating its predicting ability in CO2 capture. This is to say machine learning is gaining its ground more in chemistry field also. Okay, so I'd like to acknowledge everyone that has given me the opportunity to do different machine learning projects in chemistry. And the common thing about everyone is they actually don't shut me out when I want to say, okay, let's try machine learning in this research area. They've always given me that attention and always cheer me forward to also always go ahead and implement the technique in chemistry field. And thanks to MasterCard for funding my my scholarship here at the University of Cambridge to know more about how machine learning could be used to address climate change crisis. And that will be all for me. Thank you so much for listening.
الصلاة والسلام على رسول الله